It is 3 o'clock, 3 o'clock on a 5th of July. I think most of you are already smiling a little bit here on the side because holidays are really around the corner. But just before that, one of the hottest, one of the coolest, one of the most amazing topics in epic laser cutting. Welcome for the next 2 hours of business scouting. Every Star Wars fan knows by now that lasers can cut. I am proud to say that reality goes well beyond sci-fi on this topic. Today's lasers can cut through over 12 centimeters of steel in just a few seconds. In laser cutting, you can even laser cut something in 2D or 3D. 2D reminds me of a Spanish butcher carving a jamón ibérico, while a cut in 3D is the combination of cutting and sculpting. Though lasers are a bit more accurate than chainsaws, perhaps Michelangelo would have loved lasers as much as me. In the professional 2D laser cutting business, the biggest challenge is to have a clean cut for a given material, producing the minimum surface roughness at any depth, and even sometimes through a multi-layer of different materials. I am extremely excited about how my passion for adaptive optics is making a difference in solving the 2D challenge. The use of adaptive optics by companies like Prima Power allows the operator to change the speed and quality of the cutting, regardless of the material, its thickness, and the cutting application. And that's 2D. How about 3D? There is a trend that steel and other materials need to be cut and beautifully sculpted with the highest precision possible, resulting in automotive parts that are almost a work of art. In 3D, the challenge is twofold: precision and throughput. And the biggest trend of all is to combine both 2D and 3D cutting processes into the same machine. So for the meeting on July 5th, we have decided to do something different. We have selected our most important laser cutting systems integrators in EPIC, TRUMPF and Prima Power, and we'll explore ways for them to be even greater with the help of the EPIC members. And we will of course address the big dilemma here: CO2 or fiber lasers. Do you manufacture infrared camera systems for real-time inspection? Or maybe you provide laser beam shaping solutions to have the perfect beam for cutting through any material. Perhaps your business is high-power lasers and you want a reality check of their applicability on the laser cutting world. And most important, are you an end user of laser cutting? Share your challenges with us. This will be another meeting of the minds, from optics to lasers, from metrology to robotics. Do not miss this one. On Monday, July 5th, our Zoom room will bring together the laser cutting community to discuss changing trends and new opportunities. Trust EPIC to always be on the cutting edge. And we are on the cutting edge of this beautiful afternoon. I'm having so much fun making these videos. Markus, I love it. I had to feature you in one of the upcoming ones. Really, today we are scouting over the entire value chain. We have companies like Infineon talking about the challenges on laser dicing. And as I said on the video, we have the laser heads of Precitec, and then TRUMPF and Prima looking for strategic partnerships in laser cutting. It's going to be epic. I would like to say that I'm also, like you, dreaming about the summer holidays. It's been an amazing pandemic times with EPIC, and in September, I think most of us are going to be, I think almost all of us vaccinated. I can't wait to start traveling again and visiting all of you. I have promised so many people that I will visit them during these online technology meetings. I'm going to fulfill all these promises. As usual, my name is Jose Pozo, the CTO of EPIC, and I speak on behalf of a lovely group of friends, which are the staff of EPIC. Together we provide you events, network, investment. The biggest way is to find a job in Photonics, jobsinphotonics.com, and lots of market reports that for free because you are fantastic EPIC members and we love you very, very much. Today is the last but one Epic Online Technology Meeting on Season 4 before we go to the swimming pool in summer. Next week on Wednesday, the Mid-Infrared Alliance of Epic gets back together to address the topic of industrial manufacturing. S-WIR, M-WIR, L-WIR coming together to solve the problems. But today is all about laser cutting. And this meeting wouldn't be possible without the support of our sponsors today. First of all, coming all the way from Vilnius, Lithuania, Optoman. You're looking for a partner on IBS coatings, on hard coatings, on optics. Optoman is your partner. You're looking for any kind of optics, I mean, from graphene coated optic all the way to freeforms, Edmund Optics is your partner. And if you're looking for a company that provides the highest resolution in aspherical and freeform optics, then you have to go to Jena, the capital of optics in Europe, and meet the star, the racing star in the optics world, asphericon. But with this, I would like to also give the word to my racing star, the laser expert, the most lovely person in the Epic staff, Dr. Francesca Moglia. Thank you very much for the hard work you have done bringing together the laser cutting community. What's going to happen in the next 2 hours?
Thanks a lot, Jose. Thanks a lot for the introduction. In just a few minutes, we have this order of speakers that, as you see here, they are great representative from the end user side and from the integrator side, from laser cutting. But as you already did, very good, we want to see all of you actually that are in the room here, at least that sign up for this meeting, and it's great. So we can see here already where is the interest. So end users are coming from different fields. So semiconductors, glass, advanced materials, stainless steel. So they are all there to listen to what it does really mean laser cutting and which are the future challenges depending, of course, on the material and on the workstation that is working there. And of course, talking about workstation, we have all the laser workstations represented here, also in one of our boxes. So thanks a lot for joining us here today. Of course, it's important that laser workstations talks also with the laser technology experts. Also, you see, all in a row, just from the top to down. But then, of course, we have all the rest of the supply chain. So we have equipment, precision optomechanical systems, scanning, of course, the device is very important. Adaptive optics, let's not forget this because we will talk about it later. Metrology and inspections, of course, our laser heads are also there. And also, all the possible parts of that is included and important for laser cutting and that they can answer your challenges that will be presented today. And now, just to start with the first challenges, I give back the word to Jose.
Francesca, it's not a challenge to hear me, is it? I would like to say one thing to you. You know, this is the 100th online technology meeting of the season. And with 100 meetings, I always get the same question, the same email after this meeting. Why was my logo not in your slide? This slide only represents the companies who registered for the meeting today. So if you are an Epic member, and you don't see your logo on this slide and you would like it to be, this only means you forgot to register for this meeting. Don't let it happen again. Go to epic-asoc.com and there all the events are listed, registered to the meetings that are relevant to you. And your logo will always be in the graphical representation of the participant list. This meeting is also live streaming YouTube. So hello, YouTubers of the world. Thank you so much for keep following week by week this online experience. If you want to get in touch with any of the participants today, drop me a line, jose.pozo@epic-asoc.com or follow me on Twitter or LinkedIn. If you want to get in touch with any, I will make the introduction personally, and I love doing that. And of course, this is also valid for the people with me in this beautiful and sunny afternoon in the Zoom room. Please use the chat. There is a chat. It's a private chat. Nobody will know what you're telling others. So please use it to get in touch with anyone in the room. This meeting is about getting connections. Of course, after the meeting, if you couldn't talk to the person that you really wanted to, send me an email. I will make the introduction for you to do business. And that's it. Let's get the meeting rolling. We wanted to start this meeting with an end user perspective. And when it comes to large market, the semiconductor market always had very important challenges in the business of laser dicing. Taking one of the suppliers, Disco, but we really have Infineon in the room. Benjamin, one of the stars of the Epic Network. Benjamin, thank you very much for taking the role as the opening speaker today. Tell us how the Epic members can help the laser cutting of Infineon. The floor and the attention of everyone goes to you.
Thank you very much, Jose. And I hope you will like my presentation. I will jump right into it. I hope you're able to see the screen already.
Crystal clear.
Very good, very good. Yeah, maybe to answer Jose's question about CO2 or fiber, I guess we would then choose the fiber, or maybe solid state would also be pretty nice for us. But yeah, welcome to my talk, meeting on current and future challenges for laser cutting. The last meetings I introduced Infineon in general a bit deeper. So I want to highlight today a little bit the facility where I'm located. So we at Infineon Villach have a pretty strong position because we're combining all three key silicon materials. So we're the competence center for thin silicon manufacturing, as well as the global competence center within Infineon for silicon carbide and gallium nitride. We're introducing our new fab. This will happen in the next weeks, which is an identical production environment to the facility that we have in Dresden. So we have one virtual fab, which is also very interesting. Infineon Villach itself has roughly 1,800 different products, and all of them needs to be separated, and many look very different. I will talk about this in a bit later. So last year, we roughly manufactured 1.4 billion chips. And out of fun, I calculated that for the time that we sit together in an EPIC meeting, like 2 hours. In 2 hours, we're manufacturing roughly 1.8 million chips. And where are these manufactured? This is here. So this is our facility in Villach. We have here the new fab. Now it's finally finished, and I think here 1 or 2 floors are still missing. Nevertheless, this here all is the production area where here 300mm silicon takes place, and here silicon carbide and gallium nitride. All these are kind of R&D and research buildings. So let's talk about semiconductor laser dicing and what is interesting for us. Of course, we have the key bulk material silicon, and now the little brother of silicon, silicon carbide. We have gallium nitride. Gallium nitride is more like an additional layer, which is supported by silicon. It means if you have a gallium nitride application, it's a combination of GaN grooving mostly and silicon dicing. Then we have epoxy materials to cover certain areas of the wafer. We have imide and different kind of metals. Metals are needed for connections and also for process control monitoring structures. The wafer sizes that we are dealing with are starting with 300mm for silicon, roughly you can 200mm, very little silicon, gallium nitride more, and 150mm the silicon carbide. 4-inch, very little, just yeah, some special projects. And where do we manufacture? In a clean room environment, and this runs in a 24/7 production, which also gives a lot of things that you have to look on if you do process development. We have a high automatization, so the 300mm in general should be fully. So the idea is you have a dark factory, you can shut out the lights, and you don't need any operators to do any handling steps. You see here OHT, the overhead module that is transporting from station to station the carrier, the lot. And we needed automated process control. I think I mentioned that in the previous meeting. We want to collect as much data as possible, like standard tool parameters. Yeah, we want to get from the tool and we want to store them. In general, 2 dicing approaches are interesting for us. It's the full cut dicing, where you really focus with your laser beam on the surface and you start ablation until you dice through. This usually comes with a heat affected zone and you create thermal damage to your device. I will talk more about full cut dicing in the following slides. One other interesting aspect is the non-ablative laser dicing. So here you do a modification inside your material, and by applying an external force, these modifications get connected and you have a cleavage of your sample. This is usually very, very nice because it's A, fast, and B, you have a low heat affected zone, but it has the drawback of unique transparent materials, and you not always have them. So the full cut dicing plays a large role in the semiconductor manufacturing. And as you can see here, this drawing was done by my master student, Samuel Graf, like, hello and thanks for this. And this is how we usually set up the dicing. So the wafer is carried on a tape and frame to stabilize. And of course, the dice would get loose if we don't have any carrier. But what you can see, we create recast and we create a heat affected zone. I mean, it's obvious it's a thermal driven process, but this is reducing the mechanical stability. And what is our goal always is to minimize this heat affected zone. And as you can see, there are a couple of tricks you can do. So the fluence and your cutting depths, they don't scale linear, they're logarithmic. That means if you put 3 times more fluence, then you're not cutting 3 times deeper inside, but you have kind of an efficiency loss. And we laser engineers, we consider efficiency or cutting efficiency as the depths that we reached divided through the energy that we had to spend on a certain area. And if you see that, it's clear that your sweet spot for machining is usually at lower fluences. And there are a couple of tricks to come into this kind of range. So on the one hand, you can increase the area. I mean, there's the line focus or multi-beam, where you're always manipulating more or less the area. Or you can scale up the repetition rate and then work with a round beam. I will also show some examples of this. But here I did an easy trick. So I used the DFL 7562. It's a commercially available platform from Disco, where you have the nice possibility to change the length of your elliptical beam. So I configured 3 different lengths and the rest I left unchanged. And as you can see, I could come closer to the cutting, to the highest cutting efficiency by changing the length. And this then did lead to a higher die strength and also to less tensile stress that we have in the sidewall. So what else is interesting for us? Silicon carbide. I mean, it belongs to the wide bandgap materials. So compared to silicon, it has a couple of benefits. So the thermal conductivity is better. You can realize higher switching frequencies, and also the breakdown electric fields are higher. But yeah, it's a very hard material and therefore not easy to process. And to gain here some knowledge, we teamed up with TRUMPF. They have a very nice setup where they can easily scale down all the pulse duration and on one laser head, which is very attractive. But what we find out, silicon carbide behaves similar like metals. So we see here at 1 picosecond, we reach more or less the maximum efficiency, and reducing pulse duration is not leading there to any beneficial ablation behavior anymore. And also we had a deep look into the megahertz and gigahertz burst, because there was a lot of discussion that gigahertz burst is something very interesting. And also what we find is that the ablation rate can be scaled up. That means compared to single pulse or to megahertz burst, we have a higher ablation rate. So we found that on silicon as well as on silicon carbide. But the quality was much decreased. So it behaves like a nanosecond application more or less. But due to the flexibility that TRUMPF offers, it gives you the possibility, for example, to use both of Bohl's worlds. You can do a fast ablation rate scan with gigahertz processing. They remove a lot of material. And then finally, you do the megahertz post-polishing. Then you can also achieve a very nice roughness. And then you can see here, qualitatively, it looks very attractive. Yeah, one little epic success story that I want to highlight is one of my first meetings, I met Lars Penning from NextCam. We was introduced by Epic, like I think Francesca probably. And so we decided to look deeper into the USP polygon vendor. And our idea was, we really wanted to see if USP can deliver this qualitative benefits compared to nanosecond with the sensible throughput. And therefore we tried to follow Beat's approach. That means we were sitting on the highest efficiency, but as you can directly see, you're working then with low fluences. And therefore you need to be fast. You need to do many overscans. And here Lars comes into the game, who's delivering the right equipment, the polygon scanner with a 300 millimeter scan field. And I want to show you one example, what for example is doable, and a processing called interleave. with each second pulse you leave open, and then on the next overscan you fill that gap. That means you have double amount of overscans, but it's very nice for the heat management. And you can see here the same parameter settings. One time is creating a lot of melt, and with the interleaf approach, we're able to reduce this heat effect and melt quite a lot. All this is possible due to the fast scanning speeds, and yeah, very, very attractive. So the last slide, the epic slide, I think my time is running up. But what we can do for you, of course, working, as I mentioned, on innovative state-of-the-art semiconductor technologies. Then we have a 24/7 production, which is also very interesting to develop process for this kind of mass production. Then we're giving master thesis and internships, and in general, we are hiring at the moment. So feel free to have a look. Now, but maybe what's more interesting for you, what you can do for us. We're talking about a lot lately about advanced live process monitoring. That means now I get a lot of basic parameters like, is the right power adjusted, frequency, speed, but can I get more input from my process point? Can I check the plasma? Can I see endpoint detection? Now I did cut through. All of these kind of things are very interesting. Also, if you have innovative process improvements, if you say, I will add such and such, and then you have a better quality or a higher throughput, of course, this is always interesting for us. Then if you do simulation of laser matter interaction, that is also very interesting to understand that also theoretically in simulation, what is happening then during dicing. If you have a lot of stacks, this is very soon very, very tricky to think through. New approaches of analysis. Lately, we checked I think 1 year ago, Raman, which also gives a feedback about tensile stress. But if you have any good ideas how to measure heat affected zone or tensile stress levels, then please. And fundamental research, of course, as I just showed with TRUMPF, what also would be very interesting would be to get a deeper understanding of how diffractive optical element dicing works exactly. I mean, we have for the elliptical beam and for the round beam, it fits very nice with theory of Beat Neuenschwander. But for multi-beam, we have there some hiccups to do a nice fitting. If you have some good ideas or experience, also very welcome to talk to us. Yeah, that was my presentation. Thank you very much.
Thanks a lot, Benjamin. Thanks a lot for your contribution. Thanks a lot for this nice slide on the epic epic wavelengths, let's say, following always our suggestions. So I would say now in the room we have a large choice. We have a few friends of Benjamin. We have definitely future possible friends of Benjamin, and also some questions. So I'm embarrassed by all this choice. So I will start first with a friend, because it's a pleasure to have here Christoph from Disco. So Christoph, if you are there, you maybe can say a couple of words on how Ben is your friend and you are a friend of Ben, and how we can become also friends of Epic, and so we and you. And now maybe a couple of challenges about Disco and what Disco is doing, of course.
Sure, of course. Thank you very much for this nice welcoming. So my name is Christoph Erple. I'm working in sales for Disco, actually for the European affiliate, which is located in Munich. And yeah, Ben is one of our most important customers, since we have a lot of business ongoing. As introduced by Ben, Infineon is using a lot of laser technology for a big variety of materials. And for this application, also our tools are used. And in the past 24 months, we focused together a lot of new projects and also investigations. One was presented just now by Ben, that we studied more the theory behind the relation between cutting depth fluorines to find the most efficient laser dicing. Also with a nice success that we could really prove that the right choice of laser parameter and hardware can reach to better quality and higher die strength. Yes, maybe for the ones who don't know Disco, so we are a Japanese manufacturer. We focus on dicing all kind of wafers. Our original is the mechanical plate dicing, but since nearly 20 years, we're also in with the laser dicing in this. We see in the industry is becoming more and more challenging and more demanding. So we have more materials, but also because the materials become thinner and having bigger backside metallization, for instance, the traditional blade dicing gets more challenging. We're facing issues that the laser dicing is the only reasonable solution. And that's also why we are looking really forward to this laser technology for more and more future applications. So whenever you have any challenge in your production, any questions, feel free to contact us.
Very good. Thank you, Christoph. So, but let's keep on talking about your challenges first. You know, don't forget here you have the full photonics world. Those who are not here are here. So the 700 members plus that we have now. So you said, okay, you have a challenge for very thin materials to cut, but these are something that the people here in the room can help you with. So laser manufacturers that maybe can directly talk to you, or special optics that you might need to integrate. Do you have some ideas already on your plate?
So for sure, our entire R&D is located in Japan. So this is really the site where the innovation is driven. And my colleagues, for sure, all the time looking for new kind of laser heads, especially now looking more and more into ultra short pulse processing, picosecond and femtoseconds, including the required optics. So we have also projects ongoing using multi-beam polygon scanners. So all kind of new innovations, which can also help us to meet the demands of the end users. Those guys are welcome to contact me, and I'm happy to make also the contact then.
That sounds very good. So you are our ambassador. Thanks a lot. So now that you named all of these things, of course, we have everybody representing any of the things you said here. So I would start with Darius, because in your order, you started with ultra short pulse laser. So he has even a question for Benjamin. So please, Darius, can you introduce yourself and, of course, make your questions, please?
Thank you, Francesca. Thank you, Benjamin. Yes, so I represent Fluence. We are a company producing ultra-fast lasers and femtosecond lasers in particular. And one thing that we do is what you, Benjamin said, that we want to make people aware that actually having there's this optimum fluence to work at. So it's actually more beneficial to have more powerful laser, more powerful and less energy per pulse, so you can operate at higher repetition rates. And my question is what was the maximum repetition rate you worked at having this optimum fluence?
The maximum at the University of Bern, I have to double check, but I think maybe Lars, you can help me out on this. You know this by heart? What was the max repetition rate that we needed? I think around 8 megahertz. Oh. Check.
Yeah, that's hi Ben, good afternoon, and everybody else, by the way. I think so. Right, so the range between 8 and 10 megahertz is doable in these days. Yeah, correct.
Yeah.
Okay, thank you very much.
Well, then, I mean, it's a clear. Lars was, of course, on my on my to-do list of introduction. So this Lars is the same Lars you saw in the picture of the collaboration.
But maybe I can ask Dario something real quickly
sure.
back. So you also have an application lab then, because if you want to work in the optimal fluence conditions, then you need to do some testings, I guess. So do you have there also an application lab where you can do the dicing, or?
Yeah. We just opened a new application lab in Wrocław, so the southwest Poland. So yeah, so we are open for any kind of collaboration. Well, at the moment we have 30 watt, so it's not a lot laser up there, but if you need some 60 watts or higher of average power, it's also possible. So just you can let us know and ask.
What about the pulse length?
Well, we do it very nice, right? So it's let's say from 250 femtoseconds up to 20 picoseconds.
Very good. So that's the range. So now just one word to go back to Lars, because he was asked as a suggestion giver, but maybe you can also spend a couple of more words about what you do and what you can do also for the audience, Lars.
Okay, so now we were introduced to Infineon through the Epic event. So again, thank you for that, because it was a very interesting meeting. And based on that, we started with process validation, as Ben already mentioned to the audience with the Bern University. So what we especially liked, all of us, so all the parties involved, is that you can combine process development with hardware development, that's being fed in by input from the end customer, and that is the most important topic, because they are the only ones who can qualify a process, so you can adjust the solution you're looking for. Because in the end, there's no solution fits all. There's always tailoring the solution in order to meet a specific throughput or quality output on specific materials. And I think that is the lesson learned from the exercise, and we're going to repeat that with other applications as well. So again, that was the lesson learned from that event. Yeah.
Thanks a lot. It's really good for us to know, of course, that this is a success story that we have sitting and talking and really explaining also about projects in the future. So for us, it's just a really great message of successes from our activities. So now, let's not forget my list. So also, as Christoph said, he was talking about maybe optics or beam shaping maybe. So now it's time to give the words to Kylabs. So Fabienne had a question in the chat. Maybe you can ask yourself and introduce briefly yourself as well in Kylabs. You're muted still? Yes.
Yes.
Yeah,
thank you very
perfect.
much. Thank you very much, Francesca. I was just looking for the microphone. So basically, Kylabs is a French company doing beam shaping, and on the quite original form, because we have only reflective beam shaping, which is basically compatible with all scanners and so on, and the whole chain of optics that you may have before your process. And it's all reflective. It's, I think, quite original, and it's basically also compatible with any industrial processes that we might fit, where some other type of shaping are maybe not the best. Normally, solutions for beam shaping are very good in labs, but not so much in the field. So to go in some details, I think it would be good to have one-to-one conversation. It's much better, much more easy discussing one-to-one on your process, because we are basically also providing some very adapted solutions. Nevertheless, I would suggest that you can just look at on our website. We are focused on fast lasers like femtoseconds, but we also have solutions for welding or cutting for kilowatt lasers up to 24 kilowatts even. So we have a high activity on that. I believe we may have some solutions for you, but it needs to be interactive. So I would say difficult to discuss with everybody here on the line, but one-to-one, I believe, is really our focus.
Yeah, thank you very much for your input. Sounds interesting. Let's have a call.
Benjamin, question in YouTube for you. And this question is coming from a Swiss company. This Swiss company is called Sinova. They do water jet guided cutting. And they are asking, you normally operate in clean room environment, which normally makes lasers, conventional lasers, preferable, but there are difficulties always with silicon carbide processing. Do you think a water system could be interesting? Have you considered that? Have you evaluated that?
Yes, I mean, we tried that 8 years, I think, ago. But the water jet causes also some troubles. But maybe we can discuss it offline. But with the water jet and the frame, the tape and frame, it's not so easy. So yes, we had a look into that.
You know, I have a personal passion for water jet cutting. I do. And actually, our member number 700 was a company in Germany called LIDROTEC. Do we have anybody from LIDROTEC in the room?
Yes, I'm
Alexander,
here.
my friend Alexander, I love your video when you got the present and you opened it. Thank you very much for being here. Alexander, you just heard from Benjamin. They have evaluated water jet guided cutting. What do you bring to the table and what kind of cooperation can we do in this business?
Yeah, I mean, I think your transfer was water, basically liquids, and that's kind of what we do. So we use liquids to cool and rinse the wafers while we cut them with a laser, but not in the same way as water jet dicing. But yeah, basically with our technology, you can probably cut a little thinner and with a little bit less waste than if you just use the laser without liquids.
My colleague Francesca told me that you have a beautiful slide to show this, for everybody to get this graphical feeling in their heads.
I do. If I'm allowed to share, then I am. So let's go.
You have all the power. Yes.
There you go. So I mean, this is how it can look if you cut without liquids. You know, you have debris, you have heat accumulation, you have thermal stress or cracks and chipping. And with our liquids, and it sounds super trivial, but with our liquids, we can basically avoid all these problems, and then you can achieve results that look like this in wafer dicing. So yeah, thin cutting curves, no thermal defects, fewer micro cracks, and also clean surfaces.
One of the biggest challenges for Infineon is throughput.
Maybe I can quickly comment on that.
Benjamin.
Yes, we know LIDROTEC, and hello, Alex. So
hi, Ben.
We like their approach very much. It's a good idea, and I think it's a very interesting approach. Nevertheless, I think state of the art doesn't look as bad as Alex showing, right?
No, you're right. Yeah, that's right.
There is a follow-up question in YouTube, and this one is coming for Skylabs. They are very interested about your beam shaping technology, but they are wondering, can you perform fast beam shaping? And if you can, how fast?
Actually, no, not fast beam shaping. So what we're using at the moment for beam shaping are diffractive optical elements. And of course, there is no fast switch then possible. Nevertheless, I think 1 year ago, I started to look in SLM to be able to do these fast movements. But the contacts that I found did look that it's not ready for 24/7 production at the moment. But maybe you can teach me better. Yes, it's interesting.
I want to. For me, fast beam shaping is a big challenge. Let me address the Skylabs. Fabian, yeah. Can you perform fast beam shaping?
Yes, basically our solutions are totally passive. So basically what we do is that we are just taking the speed of the laser. So if you have a femtosecond laser going down to 250, 300 femtosecond, it is absolutely possible to shape the light there.
I think that the fast beam shaping is to go from one shape to another shape. So there is the active, as Benjamin said, the SLM is one solution. There are others. I'm very impressed with what Skylabs do. Do you have some numbers on this transition time from one beam shape to another?
To be honest, what we do is not a dynamic beam shaping. So normally for the process, we would do a standardized form that is predicted before or shaped in the lab, I would say, and we would fashion a module for that. We also have modules we can transfer. Change from one beam shape to another beam shape, but this has to be preliminary managed, right? So the transition time is just a motorization changing from one form to another in this case.
The topic of beam shaping is super interesting for EPIC. You know, we really care very much about this. Benjamin, I want to introduce you to a company called Kioba. I think there is a clear cooperation business here to do active beam shaping base of SLM. But one of our key companies in EPIC in beam shaping is also HoloOr. And Karen is here with us. Karen, good afternoon. I think you have an interesting room for cooperation with Benjamin. Please let us know. Oh, we can't hear you from Israel, which is a pity.
Can you hear me now?
Loud and clear.
Okay, great. So first of all, hi everyone. Nice to meet you all. Yes, Holler performs beam shaping or beam splitting via diffractive optical elements. We manufacture the DOEs, and sorry, I just put a message. And we actually have just recently launched a new product that enables shaping from spot to ring. So that might be very relevant for certain applications in laser welding and cutting. And you can change back from the single spot to a ring shape with the full dynamic range during the process. So this might be extremely relevant in several applications. And other than that, multi-beam approach, as Benjamin mentioned before, is something that we've also successfully done with a lot of our customers. So this can be extremely interesting.
Benjamin, where do you stand on multi-beam? Is this solution being, I know it's being evaluated. What is the key challenge there?
I think for multi-beam at the moment, we're struggling a little bit to find a theory that fits everything together. I mean, I like if I understand my process on a theoretical point of view, and there we did a lot of research, and actually my master's student is also watching on YouTube. He spends a lot of time to investigate their approaches. But yeah, Holler we know, and Israel and Nathan, we already in contact with them. Thank you very much.
I am very big fan of multi-beam solutions, and you should know that Lars is in a project called Lampas, and he's actually making a breakthrough on this. But still in the field of beam shaping, one last comment. I want to give the floor of a company that means a lot to me personally. Dynamic Optics is in the room. Stefan, what do you bring to the table?
Well, hello, everybody, and thanks, Jose, for the introduction. So Dynamic Optics is a company that manufactures deformable mirrors, and we have a long-term expertise in deformable mirrors for high-power lasers, also high-intensity lasers. So we have been working many times in the last 10 years with femtosecond and picosecond lasers. We are also more recently going towards the direction of building system for continuous wave lasers up to 4 kilowatts. So what we can offer to this discussion is the deformable mirror that can change very rapidly the shape, the beam shape of your laser from Gaussian spot to elliptical beam, and also to more complex shapes. So if you have any application that might benefit from this type of control of the beam, please feel free to contact us.
Benjamin, deformable mirrors, how do you look at it?
Interesting. And I have 1,800 products here that could be interested.
I am quite amazed by this technology, deformable mirrors. This is a big breakthrough. Francesca, what a way to start the meeting. Take over, please. This is your meeting. Sorry for that.
Thanks a lot, Jose. Yeah, then I mean, if everybody wants to speak with Ben, we have to let them speak, right? Come on. So later on, there are also options to talk later, but I didn't forget that Christian is also having a question. So let's conclude the direct discussion with Ben, with Christian from Optoprim, famous for added value distribution, that wants to tell us a bit about the added value, right, Christian?
Correct. Yes. No. Yeah. Thanks for introducing, Francesca. So Ben was mentioning also process monitoring, and I think it's a very important part of every laser process. I would be first interested what you are using up to now in your process, and if you have heard about acoustical process monitoring, which is especially very interesting for pulsed lasers or ultra-fast pulse lasers, because they create very loud noise, and especially in ultrasound.
Yeah, so first, sorry, I cannot really share how we're doing at the moment. We really like to have as much as possible, and whatever is new, we take it. Acoustic, yes, but not for the dicing. I'm also working at the other application completely away from dicing, but also laser modification, and there acoustic is interesting. But I would like to learn more about it. I'm pretty new on this field, so we use it in one application, but not what I was showing. If you have some interesting ideas, please.
Yeah, I will share very quick my screen so you can get maybe a first idea how that would work. So as we are adding value, we're working with different companies as a distributor in Europe, in Germany, in France, in Italy. And in this specific case, we're working with a company from Austria. It's they building this little and very small compact optical microphone. And that's basically like in the Tone Studio, you add it to your process. This little device absorbs the acoustic from your laser process, and we can interpret it. And it's very good for evaluation for process parameters, but also for really live monitoring for production processes. And there's some other slides.
Also for endpoint detection, it could be very interesting, right?
Yeah, as well. So here's the principle. So this is a small laser resonator, and the sound kind of influences the light. We can interpret this, and the specific thing is we can detect the ultrasound. And here is a small slide where you can see that we can hear much more than the human ear. We really go up to 1 megahertz, and that helps us for a lot of processes, like in the next slides, like for a welding process, for another welding process in terms of that, but especially like this fast cracking materials, for example. It's very sensitive to hear the process, but also cracks within the process when you have icing processes like at your place. So if you want to learn more, we are quite open to introduce a little bit more to this new technology, new way for process.
Would it be possible, just to play an example? I have an imide layer that I need to remove selectively. Probably that sounds different than when I cut the silicon beyond. So can you, with your acoustic, tell me if I'm cutting imide or if I cut the silicon?
Let's say I can't answer you that with yes or no, but let's say as this might have different, at the end we are measuring the impact or the, how do you say, the power which comes into the material, the reaction with the material, and every different material absorbs it differently, so you get different noise levels. So we should easily detect the differences between this kind of different materials. Yeah, that should be possible.
Very good.
Also going from one layer to the other. So when the material changes, when you have multi-layer materials, that's for welding, and for cutting, it's most of the time quite easily and nice to catch.
Yeah, then the only way to know really for sure is to try it, right? So
correct.
Let's keep in touch then, if you can connect to each other, otherwise we can help you. That's the best way to find out if there's some room for collaboration also in the semiconductor world, different materials, cutting and welding. Thanks a lot, Christian. So now it's time to go on with our agenda. Thanks a lot, Benjamin, for your contributions. And of course, stay tuned. There will be questions that maybe you can sneak in and still ask. I know you very well. Now it's really time to go to Precitec. I'm really proud to have here Markus in the room. That is our expert, one of really big experts in a lot of laser-based processing. And today, of course, we could not let him talk about the laser cutting experience at Precitec and of his own experience that is also a big bag of it. Right, Markus? Thanks a lot. And we see the slides. The floor is yours.
Yes, Francesca, thank you very much for the kind invitation. Thank you for having me. And yes, maybe there should not be any kind of cutting webinar from EPIC without Precitec. Why Precitec? I would say Precitec is one of those pioneers in laser cutting. So why do we do cutting? It's still a big market. I introduced that slide here, which is one of those market estimations you find on the internet or on some other experts' books. Laser cutting is still growing. Laser cutting is still growing. And especially you see that here for Europe, especially laser cutting is still growing in Asia. And Asia is one of those areas where Precitec is selling the most cutting heads too. Just to get you a number, we are selling thousands of laser cutting heads per year. So it's a huge business. It's a huge business for Precitec. And as I said, Precitec is a pioneer. So I took the chance because Precitec is getting 50 years old this year. So Precitec was founded in 1971. And really 2 years after Precitec was founded, there was the first patent application on technology to control the distance of a cutting head to a metal workpiece. And still, that capacitive distance control is the heart of every cutting head worldwide. Every cutting head worldwide who is doing metal cutting lives on the technology, on the sensor technology of capacitive distance control. And as you see, so our first German patent was applied in 73. The first US patent was applied in 76. So it's definitely before Trump even had lasers, Precitec had the cutting technology, the distance technology. And so one excerpt of product portfolio, Precitec is building cutting heads for everything. But everything besides cutting of non-metals, I would say. So the presentation before was extremely interesting, but unfortunately we are not in the business of non-metals. We are mostly in the business of CW lasers. We are mostly in the business of high power lasers, extreme high power lasers. And this is what we are facing today. We are facing today that customers are asking for cutting heads which stand 30 kilowatt and more. And the Pro Cutter 2.0 family, which is the most sold cutting head today at Precitec, the non-zoom device you see here framed, this is the one which stands 30 kilowatts. We also have a cutting head with a zoom device to change the focal or the spot size very fastly, but this head is only capable to stand 12 kilowatt. So I do have a short video here on the 30 kilowatt Pro Cutter 2.0 and the features. So I will explain the features in detail after that video, but you see this is the kind. So what did we do? So first, we have a very, very fast, highly dynamic drive for focus adjustment. This is important for the cutting, but it's more important for the piercing. I will come to back to that later. So we increased the standoff of our focus lens to the workpiece surface in order to be able to have a better quality cut. And for sure, we increased the quality of the optics and the coating of the optics in order to not to get a high focus shift. And for sure, we need some cooling. So that's why we can present very, very nice, as you see here, 40 millimeter stainless steel cuts, which are definitely comparable to plasma cutting. And this is actually what we are talking about. It's all about productivity. It's all about quality. Laser cutting is about productivity and quality. It's mass production. So as I already said, so we have increased the standoff of the focusing lens to the workpiece surface, and we have increased the dynamic movement of that focus, because we use that on a lower position during piercing and on a higher position during cutting. And piercing is one of the most important processes where you can increase the productivity, because if you have a very fast piercing process, you can increase the output from 3 to 6%. So as I said, it's a very high dynamic drive. There is minimum idle time between piercing and cutting, so this makes cutting processes fast. And as I said, we worked with our suppliers on the bulk material, we worked especially on the coating of the optics in order to dramatically reduce the focus shift. Focus shift is if you're working with 30 kilowatt, if you're working with 30 kilowatt in 24/7, then focus shift is a very, could be a dramatic game changer and a process killer, I would say. And if you work with 30 kilowatts, you still have a very, very high back reflection. That means you have to put in some special cooling on the tip of the torch at the lower bottom of your cutting head in order to cool down that device. So as I said, you can easily cut very thick material. Just some words about the Precitec, which is what we call the piercing process, or the technology behind. So that Precitec technology is not dependent on the laser source. It works with any laser source. Precitec is just selling cutting heads. We are not in any case dependent on the processing laser. So this is important to know. We are still independent and we sell cutting heads in all machines. So that's why we need to be able to communicate with any kind of laser, because communication with the laser is crucial for the piercing process. So what you see here, some examples with Precitec technology. It's a very clean process. Again, you see here on different material thicknesses. So if you know how to pierce, if you know how to change the laser shape, the shape of the power during pierces, you can increase piercing process dramatically. And there's a sensor. The sensor in the cutting head or in the laser, it does not depend, as I said, on the location of the piercing sensor. It's detecting the process emissions, and it's telling you what to do, how to control the laser power on time. So as I said, it's a controlled piercing process. And this is important. We can also use that sensor technology during cutting to detect the cutting interruptions, because if you would not cut through sometime because of whatever happens to your machine, so it definitely it's a pity for because the material or the cut has to be redone. It's expensive, and it's not nice for the cutter. So I just introduced that slide here, just based on the presentation before. As I heard, we are working in clean room environment from Infineon. We do not work at clean room environments. So this is what we need to be, or what we are facing sometimes in cutting environments, completely dusty, completely dirty environments. And so we definitely need to take care that the inside of the cutting head withstands any kind of external dirt. Because everybody of you who is listening knows the smallest particle on the lenses would dramatically increase focus shift and will kill the cutting process. So what can we do for you and what can you do for us? So I would say what we can do for you is that we still offer the most reliable cutting technology for all the cutting processes worldwide. So it's not only flatbed cutting, which I presented with the Pro Cutter 2.0. It's also tube cutting. It's a cutting head which is able to do bevel cutting. So on an angle, it's robot cutting. So Precitec is providing cutting heads for any kind of metal cutting processes. But still, what we need. It's important that we raise the confidence that the cutting process is an alternative to plasma cutting. And why it is an alternative? Cutting heads become cheaper, and laser sources become cheaper. So we are facing the fact that you can buy 12 kilowatt lasers in China for $50,000 US. So the laser is a tool which maybe in the end will not be repaired when it's broken. So it's just replaced. So that's why laser cutting is getting cheaper. It's getting cheaper. And so we are competing against plasma cutting. This is our next goal. So to still increase sales and to still increase the use of laser technology. What we still need is fundamental research. And again, K-Labs is one of those who has to be highlighted in that way. We are working together with K-Labs in a EU government-funded project where we try out special beam shapes to improve laser cutting process. I think on the next bigger conference, we will be able to share some information on our first trials. So actually today we received the K-Labs module into our lab, and tomorrow we do the first premise measurements, and then we will start to do the cutting process. And for sure, what do we need? Everybody needs more customers. So if you're interested in Precitec technology in laser cutting, so you're welcome and to contact me or to contact my colleagues or to contact Precitec over the standard distribution channels. So thank you very much for your
Thanks a lot, Markus. Thanks a lot for the nice introduction also to another collaboration and to your challenges as well. Can we maybe go a bit deeper into the plasma competition, let's say? So you say we need to be stronger together to push for laser technology against plasma technology. Can you maybe say something more about what are your thoughts, how we can really go beyond and make a step ahead? Because we are already very efficient. I see 24/7, you are dust proof, but what are some other challenges that maybe the people in the room can help you with to reach this overcoming the plasma cutting?
So I think the goal is to continuously increase the laser power to stand extremely higher powers than that 30 kilowatts we are standing right now. So I know that some competitors on the market already followed Precitec's example and provide high power cutting heads. So this is the ultimate goal to get the competition. I think lasers getting cheaper. They will get cheaper somehow. So even though it's extremely cheap compared to 10 years ago, but they're getting cheaper. So we need to also improve the competition by bringing cheaper processing heads. This is the point. And then we can compete plasma cutting even more.
Okay, very good. So going back to maybe to the laser power. So we have in the room Stefano from IPG Photonics. Maybe you want to give a comment about how to deal with them and how to get more and how to help Markus as well, although I assume you know each other already.
Thank you, Francesca. Yeah, let's say I'm Stefano Cattaneo from IPG, and I'm in IPG since 23 years. So when the laser for cutting was only CO2 and some Nd:YAG, so fiber laser didn't exist in industrial applications. So at the beginning, when we started, we had to convince Precitec. We had a lot of discussions with Precitec. We asked them to modify some CO2 heads for starting working with fibers. And at that time, we were discussing fibers or CO2. What will be the future? Then everything moved from there, and we started discussing about beam modification. So the future for cutting would be beam modification. Then we started discussing the power, higher and higher powers, and again, a lot of discussions, a lot of interest arguments, because there is no one reason, one solution for everything. So power is good, power is the future, but not for every application. So, and here we are again discussing how to overcome the plasma. It's a very interesting question, very interesting topic. So when we started, the first laser we sold for cutting was an 800 watt. Now we are selling a lot of 10, 12, some 15 kilowatt laser per month, some 20 kilowatt laser per year, a few 30 kilowatt, at least in Italy. So the future will be definitely there, because not because it's necessary to cut very thick material, but it's good for improving the productivity on the mid thickness material. So
Stefan, CO2 or fiber?
Fiber, definitely, of course.
That's my guy.
Come on.
Markus,
Jose, I don't think that we even sell 20 CO2 cutting heads per year. So, and it may be just a replacement of already existing machines. So it's no question. So there is no CO2 cutting market anymore. Not relevant.
We had a few companies in EPIC on the CO2 side. We want to address this. I want to have a meeting CO2 or fiber, because there is still a few things to discuss there. But Precitec, for me, when it comes to cutting, I am a huge fan of your laser heads, and especially when the laser heads includes infrared cameras. In your presentation, we didn't speak too much about this. I would like to ask you very simplistically, in laser cutting, S-weir, L-weir, or M-weir?
I think there is a nice approach of TRUMPF. Maybe Mr. Müllegger will tell about that in his presentation on using camera technology to improve the laser cutting process. So we at Precitec, we are just working with mid-infrared sensor technology, but not with camera technology, because even for the piercing process, we need very fast response time and a very high of detection rate, and this is not possible with the infrared cameras today. That's why we rely on photodiode technology. But as we maybe see or if you look on the TRUMPF webpage, there is a very nice application on using camera technology to improve laser cutting, which is very fascinating.
For me, I'm a huge fan of thermal cameras. I can't hide this. We have a company in EPIC also in the room, NIT. Francois, are you with us? Francois, you're with us, but you are muted.
Yes,
so,
here I am, sorry.
Francois, so S-weir cameras is what you base your business on. What is the trend that you have seen on laser cutting for S-weir? And here what Markus said, the penetration of the market is not fully done yet.
For laser cutting itself, that is true. Today, for laser cutting, SWIR sensors are used to be able to detect defects before and after the cutting itself. It's also used in welding applications to have the thermal information in welding applications. To my knowledge, not as much in the cutting, and that's an interesting question, because when you mention that Markus, that the speed is important in terms of thermal management, what speeds are you, or refreshment frequencies are you looking for? Because thermal management, usually it's not that quick reaction. So it's if you have a 1,000 hertz frequency, is that enough for the measurement?
So it's not the thermal management I'm talking about. The piercing process, we talk about 100 kilohertz sensor technology to detect the piercing. And so as long as So, and very important, and sorry to say that, very important, it's also a question of costs. And the photodiode is still much more cheaper than a camera. So we have to bring down prices for cutting heads. That's why introducing a camera where a camera is not needed would somehow make it contradict the efficiency of the cutting head.
Okay, so it is cost driven, but
yeah,
these are things that can be tackled too in terms of costs too. So that's why it'd be interesting to have a talk about this, because
I love this topic because in my mind, a laser head is not a cheap instrument. So to what extent is the S-Weir camera, which is not an expensive camera, a driving factor in the overall cost of the instrument? I'm being a bit provocative there, Markus, but I want to address back this topic again later, because we're going to have TRUMPF, and that's going to be something that we have to bring back, the thermal management on this. But before that, one of the key companies, IBS Coatings for Optics in EPIC, is here, and Konstantinos has the hand up. I guess you have a question for Markus, correct?
Yes, thank you, Jose. Yes, I have. A very interesting presentation from Markus. Really, this 30 kilowatts sounds impressive. Well, you know, as you've shown in your presentation, optics that you work with is works in transmission. So my question is, what are requirements you're raising for reflectivity of your optics? Because from 30 kilowatts, even 0.1% is a lot. So can you elaborate on this number?
So how do you come on that 0.1%?
You know, this is easy to do. I don't know what is enough for you. Is it 0.01?
Actually, as you so you can calculate. So you're an expert on optics. So if you calculate and if you assume what kind of optics we have inside, then you could calculate what temperature temperature load we do have on our optics, and then you can calculate how much laser power we absorb. So it's better. So this is the key issue. It's the issue is that we have optimized our beam path, and we definitely have optimized the coating. The coating was that part which is the most important. For sure, we have to teach customers how to handle the optics. For sure, we do have protection glasses underneath the collimator, as well as on the tip of the torch, in order to protect the inside from getting dirt or dust inside. But definitely, we have brought down the absorption on a lower level. So that's why you can expect even more than 30 kilowatt in the future. Yes.
Okay, this is the follow-up question that I have. So what is the limiting factor for a Pro Cutter 2.0 to work only up to 30 kilowatts?
So you wouldn't get a cutting head from Precitec which would not withstand or would not work in 24/7 environment, in any environment. So any cutting head is proved. So I'm pretty sure I know that in our lab we already work with higher powers, but we would not bring out that if we would not be sure that it can stand that 24/7 challenge. And that's why we are customer driven, we are application driven, and if there is a market for 40 kilowatt cutting heads, you would get 40 kilowatt cutting heads from Precitec.
There is great room for cooperation here. Markus, please follow up with my favorite Optoman. But I would like to go now back to Optoprim. You presented the acoustic sensor for laser cutting, and that actually raised a lot of interest from Infineon Technologies in the YouTube channel. They have a question for you. can we use this for machine preventive maintenance? To listen for abnormal machine sounds as a new source of information to determine if we need to do preventive maintenance. What do you say to that, my friends from Optoprim?
Yes, yeah, thanks, Jose, for this nice question. Yeah, it works. We also tested it with customers, or by default, a customer was also reporting us during his additive process in the powder bed. He was tuning his axis in a much better way than he was able to do it before, hearing the ultrasound noise of the axis. And so you can really detect much more than the
Christian,
sound.
you need to go to Regensburg, and if you want to send your sensor in advance, I will pay for the shipping expenses because there is clear room for cooperation here. I would like to also go back to NIT. It also raised a lot of interest from the Infineon side, and they would like to study your cameras, not only for the cutting and dicing, but also for the inspection of the chips. So Francois, that's also a nice follow-up on your presentation. Markus, you're always a star at this meeting. Thank you so much, but stay tuned because now we are going to put the laser heads into Prima and TRUMPF, the biggest system integrators in laser technology at EPIC. We go first to Ditzingen. We go to the laser integrator in Europe. We go to TRUMPF. Thank you very much for being with us today. Andreas, your background is fantastic. The floor and the attention of everyone goes to TRUMPF.
So I hope everybody can hear me now.
Loud and clear, but we cannot see your slides yet.
I'm just now switching on. So what can you see now, the presenter screen or the real screen?
I see the presenters, and when you switch, I see the real. Yes.
Okay, perfect.
Wait, you need to go to slideshow mode again. So click again on slideshow mode.
Again, I will do again. So I had a lot of struggles already with this system. Now my whole PowerPoint went away. Just one moment.
If you manage to make the true laser, you will manage to share this presentation.
I will do
doubt.
my very best to do this. That's crazy. Just give me 1/2 minute, and if this doesn't work, then we probably need to show the PDF. I will stop my sharing.
In the meantime, while you share the screen, I would like to say that after the next two presentations, I would really like to have a big round of discussion here with companies introduced from like Power Photonics in Scotland or Populatech in Finland. I want to really understand if we can solve some of the key challenges. So the two main system integrators in laser cutting that we have in this network. Andreas, how are we doing?
I am now again.
You know what?
We're going my screen. And I tried on final time.
Yes,
what do
fantastic.
You see now?
Gorilla Glass clear. The floor is yours.
So I still hope that the pages will flip. So, hi everyone. Thank you for having the chance to speak to you. I brought some couple of slides on laser cutting. So I will start maybe with a quick market view, what we are currently seeing, as you probably all see this, as well as we have a slight development in the production volume of cars at the moment. But if you look at the battery electric vehicles, then we see there is a fast growth. What we also see is a huge growth of the number of models. And all of this really provides some changes in the production requirements of the OEMs and tier ones. And as we talk about cutting, of course, there are also changes in the production requirements of 2D and 3D laser cutting. In the likes of 3D laser cutting, obviously, we see here an increase of press-hardened parts, which are integrated into the car body, as also the electric vehicles have to be light and safe. And the lighter they are, the better reach they have, the smaller batteries they use, the cheaper they are. So that's why a lot of press-hardened material is integrated in the cars. But also lots of models are coming onto the market, and the manufacturers need certainly flexible solutions to produce these cars. There we brought a new laser blanking system onto the market, which I'll show you in a minute. But before coming to that, I just want to mention our most successful unit if we're talking about the cutting, 3D cutting of press hardened components. It's our True Laser Cell 8030. I don't want to show you a video. You can see this on our PowerPoint, on our website, sorry, PowerPoint you see currently. You can see this on our website, but we are really proud that this is a very successful unit which we brought into the market already. More than 1,800 systems are sold and integrated, and really one of the leading systems on the market. Well, this is how it looks like. It's a reliable system, and as I'm working also in sales, sometimes it's a little bit too reliable, as I could really say. So majority of these cells are run even more than 10 years. And during these 10 years, these systems run more than 60,000 units, so which means a phenomenal distance of 21 million kilometers of cutting length, approximately what these machines are doing. And the most fascinating things, since 2011, still 99.6% of these systems are in operation, and this makes a really tough job for all of us to sell additional machines. But thanks to the growing market, that there are still some great opportunities to integrate new systems on the market. And if you wonder about this 0.4%, which are still missing, which we don't know, they are probably somewhere moved around, so we don't have them in our systems anymore. Yeah, talking about the cutting quality, as Mr. Kogel-Hollacher already mentioned, there are a few options what we have also integrated in our systems to ensure the cutting quality and improve the productivity. Just quickly mentioning a couple of them. One is X-Blast. So here we realize a higher distance to the part, which increases the geometry flexibility, the nozzle service life, and cell productivity. Then that's what have been mentioned before. So we have the camera observation. With this camera observation, we can detect either where there are still slugs inside the cutted geometry, and we can advise that the quality is not optimum, or we can even in a professional version also check the accuracy. And the slug detection is 130 milliseconds taken for this process. Then we have focus line, also a technology which is quite nice to be able to cut also patchwork parts. If you're thinking about B-pillars and patched parts, here we can also have also a solution for such kind of things. And then last but not least, you're saying, of course, the laser sources get cheaper, and you can get the lowest laser sources, lowest cost lasers somewhere in Asia. But we still are proud, and we still are happy to have our TrueDisc laser source here, which we also nicely saw on the Precitec presentation, our resonator. But this resonator is really famous because it ensures the constant laser power on the workpiece, which ensures also the cutting quality. But now coming to our new stuff, the new stuff which will come in serial release, serial product release mid of next year. We have now a laser blanking solution, an entire turnkey solution which we bring onto the market. The specification of this solution is a working area of 2.1 by 4 square meters working envelope inside the machine. We cut with this system currently 0.5 to 4 millimeters, so it's clearly meant for the automotive body in white areas. Currently, the machine can be fed or will be fed automatically with coil, and of course, cutting speeds are mainly limited by the mechanics, not by the physics. But of course, as you perfectly know, with laser we can cut very fast. The systems consists out of a decoiler with a loading station, Then the whole coil material goes into the precision leveler to get the material flat for high precise laser cutting. We have here a loop station, which is needed if we really want to have the optimum surface quality of the parts. If this is not needed for only structural parts, we even could shorten the system and could leave out this loop station. And last but not, and as a next step here, then for feeding into the cutting system, we have pinch holes in front of the true laser system. Then the core of the system is based, and that's the nice thing here, is based on our standard true laser 3030 2D flatbed cutting machine. Within this machine, we integrated a conveyor, and then we created here this cutting system for coil. At the moment and for the next time, this system is running on a start-stop mode just to ensure the product quality as we check the market, and these on-the-fly cutting systems often have their challenge in this perspective. And then at the end of the system, we obviously have an automated robot unloading system and of course a skeleton disposal solution. Well, why? There are some laser cutting solutions on the market already, but what was the motivation for us also to bring our solution here? Of course, it's clear. If you look at the total investment from a normal laser blanking to a press blanking solution, it's really significant lower. So we are offering here a turnkey solution at a real low investment. Compared to press blanking, obviously also plant preparation is not necessary, and there are also no cost for tooling, no cost for hardware and storage. And this already makes the system quite attractive for our entry level. As you can imagine, all parties in the game of electromobility have a lot to invest, so every euro counts here for further investment. Then if you look at the operational costs, or here also here, this system is significantly lower compared to a press blanking solution. Certainly depreciation and interest cost are the major part. But of course, if you're looking at the service, if you look at personal plant preparations and the consumables, we think that with this solution, we really brought an attractive product on the market. So less service cost. Of course, we have no tools, so tool maintenance is not necessary. We have already from our standard, let's say 2D flatbed cutting solutions, already offline programming tools and simulation tools available. So we already adopt these a little bit to the solution. And then finally, have really a nice offline programming and simulation tool, which really quickly installs, develops blanks and installs new blanks and really support the customers at the implementation and the product planning. And of course, last but not least, also footprint. As I said, real estate costs are everywhere important. And also here, this is significantly different to press blanking solutions. So last but not least, summarizing, we can really say here that we offered a laser blanking solution here for a minimum operational cost, less scrap, as obviously laser blanking is a solution where we can really optimize the laser, the part positions, so that scrap comes to a minimum, and also the overall very good operational efficiency leads to low cutting cost per blank. And this is basically, or this was basically the last slide of my presentation. I don't put in the what can we do for you and what can you do for us, but I can tell you this now, that of course you have seen here what we can do for you is certainly provide from laser sources optic solutions for cutting, but also for welding, So if you need anything of that, TRUMPF is certainly a known contact company for this. And of course, we are always interested in also discussing new ideas and also discussing new applications, new challenges. As you might know, we have our application labs all over the world. Of course, the biggest ones are in Ditzingen, but also on the world. So we always welcome the customers to come with their material, and then let's do trials together and then see how the process can be done perfectly and what would be the suitable equipment on that. So thank you very much for your attention.
Thanks a lot, Andreas. Thanks a lot. So very good. You didn't have the slide, but you kept it as a last but not least communication to our audience today. But let's go a bit deeper, because of course we know you are one of the market leaders. You are already optimizing everything, maybe even on a kind of a vertical structure that you integrate all yourself. But can you maybe tell us one challenge, so one that was coming from your application lab, for example, so towards the application. Is there something that someone here in the room can help you with a little bit, improve even more what is already, as we know and as we saw, is running already very, very smoothly?
Yeah.
Challenge accepted, Andreas.
Yeah, no, this is as maybe this also was a little bit a misunderstanding. I'm not from the development side in such, so that I can tell you now, or can tell the audience, we need this sensor, we need that optic. I mean, in regards to optics, of course, as Mr. Kogel-Hollacher knows perfectly, we have a lot of optics, but when it comes to cutting, we have obviously our own optics often, because this is at least the 2D cutting side is one of our backbone, is of our core businesses. But in general, I could say certainly there are often sensors or technologies where we are happy to network together with others. It's just that in regards to these two topics, 2D, 3D cutting, I'm not aware at the moment of some specific challenge what could be solved by a certain equipment.
Andreas, the question is CO2 or fiber lasers. I know that for 2D cutting, the 10.6 micrometers has become a very interesting wavelength for the very clean, the bar-free edges in the cutting. Where do you stand on this beautiful debate, CO2 or fiber?
Of course, I have a little bit. I mean, of course, the majority already beam guidance, all the things are certainly in favor of I should say TrueDisc, but of course we also do provide fiber lasers. So let's say solid state lasers. It's clear that this is more easier. That we started with the CO2, and now we are in the majority. But still, I have to say, still we have an own CO2 laser fabrication. We are still using CO2 lasers also at the moment, also for cutting. But I have to say this is a smaller range, so the bigger range is certainly solid state.
When we talk about the 10.6 micrometer wavelength, still with the CO2, for me, the challenge there, please correct me if I'm wrong, do we have technologies to actually doing the accurate beam shaping that new applications are demanding in the optics for this very long wavelength?
I cannot tell you at the moment. As I said, I'm not the cutting expert in this. That we let's say for these machines, what I showed you now, we don't use beam shaping. So of course, if you're talking about the pulsed lasers, if you're talking about even about welding, as you might know, we have our ring beam shaping.
Yes.
For our to this. But this is joining, not cutting. So maybe we are on a different conference here. But of course, if you're talking about ring beam shaping and welding, then there's a huge range and there's a huge success at the end of the day to join faster, to join different materials. So I can talk there for hours, but that's a different topic maybe.
For me, the future is the solid state lasers and the present is the fiber. And the CO2 is a mixture between yesterday and today. In the solid state laser, you have this 1.03 micrometer laser, and that for me is the one that I would like to address on packaging, on optics, on beam shaping. But before that, I want to give the floor to Francesca that has something cool in mind in terms of making a round of questions. Frank.
Thanks a lot, Jose. So thanks a lot for the passing the microphone. So the question is, so if there is no open questions from Andreas, still there could be something offering from the audience. So we don't have questions here. So if anybody wants to raise their hands. Because, I mean, I can still go back to, Jose, let's wait a bit. So we were talking about adaptive optics for the semiconductor part. Now we move a bit to the metal part. Maybe Stefano wants to comment on this and how they are developing their optics in this direction. Do we have Stefano still there?
Yes, I'm here.
No, not from IPG. I meant the other Stefano from Dynamic Optics. But if it's not the case, I mean, of course, Stefano, you can comment as well on the other Stefano, so IPG. Please, the floor is yours.
Thank you, Francesca. No, from our side, we are working, of course, developing the optics for, especially for the very high power, where in the market, it's good that now Precitec has a solution. Of course, Precitec is the #1 in the world, so it's very good. But for very high power, there are solutions still missing. So we are working there because the future is there. So it's interesting also it would be interesting also to understand from TRUMPF how they see the very high power in the future.
So I was just unmuted. Yeah, of course there are high power applications also on our areas, thicker materials, and also joining and heating up are of course one of these applications. But if you look at the moment at our entire business, that's rather it's not playing the key role. And I'm, as I said, I'm industry manager for automotive body and white applications, and here it's certainly not used. So here we are working. It's working from 4 is perfect, or 3 to maximum 8 or something like that, and more laser power we don't need.
So thanks a lot. So thanks a lot for this comment. So Antonio, do you want to ask a question? You have raised your hand.
Yes. I am a little curious because looking on this machine, so we are speaking about coil, we are speaking on quite small thickness, up to 4 millimeter. So I think that production and productivity is a key words here. So I have 2 questions. One is how you manage the change of the coil, and or if you take in account weld one coil, the head of the new coil with the tail of the old one. And the second question is also how you manage the repeatability parts and the quality during the cutting and also during the unloading of the parts. I think that here vision system is playing a role or could play a major role.
So first of the first question, the answer of the first question is the change of the coil is a standard a process. So that's if we talk about the coiling unit before the cutting system, this is fabricated by the company Aku at the moment, and they are very famous, known for this. And basically, you can imagine it's just a process where you have a cutting. So if you coming towards the end of the production, or you have to change it. Then you have a cut circle included, which then let's say incorporates let's say an unwinding process of the coil, so it winds back, and then it's just a simple. There's a carrier. I mean, I can show this picture again if my system is working here, and let's do freigeben. So here you can see in the end there's this carrier here from the decoiler, this carrier, and then it's simply you need to have a crane, and you put the crane onto the carrier and change the coil. So there is no welding end to end inside this machine. And in regards to the repeatability and vision system, at the moment there is no vision system included. So we have the pinch rows in the beginning of this cutting machine, and these pinch rows ensure that we constantly feed, according to our tolerances, feed the stripe into the cutting machine. And by that we ensure that we are within the tolerances of the position, and entire programming was done, as I mentioned during my presentation, to our offline tool, TrueTops Boost, and this tool provides the positions to the machine as well as to the unloading station. And by that we ensure that the repeatability and the accuracy of the parts, the shape is certainly constant. And if you're talking about the stacking accuracy, also the stacking accuracy to the pallet then will be ensured by this way of programming.
Thanks a lot. Thanks a lot for this also last specification. And now is maybe time to go on, because we didn't forget we have still Prima Power in the room. So it's really a pleasure for me to introduce Marco. Marco, are you there? Yes.
Thank you.
Thanks a lot for being here. If you are ready, you can share your screen and the floor is yours.
Okay, thank you very much, Francesca.
Perfect.
Hello everybody. My name is Marco Pivanti. I'm the product manager of 3D laser machines at Prima Power, the machinery division of Prima Industrie Group. I'm working at Prima since 25 years. And first, I'd like to thank EPIC for the opportunity to take part in this event and share with people from other important companies the Prima experience in solutions for industrial application. Let's start with a brief history of our company. The history of Prima Industrie began more than 40 years ago from a group of young engineers who designed customized solutions based on a new approach, the so-called mechatronics. And the first Prima Industrie 3D laser machine has been designed in 1979. Today, Prima Industrie is a group of companies structured in 4 business units with about 1,800 employees, and it is present in 30 countries. The 4 business units are Prima Power, as you see in the slide, dedicated to the manufacturing of machines, automation, and software. Prima Additive, regarding additive manufacturing machines. Prima Electro, concerning industrial electronics, and Convergent, about laser sources. The product portfolio of Prima Industrie includes machines for sheet metal fabrication, laser machines, electronics, and laser sources. But now let's see in details what are the Prima Industrie products. First, 2D and 3D laser machines manufactured at the production plants in Italy, United States, and China. Sheet metal processing machines, punching machines, laser plus punching and systems manufactured at the production plant in Finland. Furthermore, we have panel benders, press brake manufactured in Italy. Additive manufacturing solutions designed in Italy using common platform with the 3D laser for direct deposition technology and other dedicated machines for powder bed process. Around the machine, we provide solutions for automation and storage, allowing to get fully automated lines from the metal sheets to the final product, using different technologies like punching, laser, cutting, and bending. Typical application of these automated lines are metal furnitures, white goods, elevator, air treatments, and so on. Our subsidiaries and dealers can provide assistance to our customers in about 80 different countries in the world in terms of technical support, training, and spare parts availability. In the today industrial world, the software plays a fundamental role, not only solutions for the machine control, to control the mechanics, obviously the numerical control, but Prima Industrie can provide a complete software environment, including offline programming, production monitoring, customer ERP connection, data collection according to the requirements of Industry 4.0. Okay, coming to my daily job, because I'm the 3D laser product manager, so I want to focus my attention and your attention on our 3D laser machines. We can offer a big range of solutions with the different sizes, configuration, technologies to meet the customer requirements in formed and stamped parts laser processing. Our main application is the laser cutting of automotive parts, mainly hot stamped components. So about what we can offer and what we can provide to our customers, mainly we are talking about turnkey solutions for massive production. Our solution is from the offline programming, so from the drawing of the part, including then the machine, laser cutting, automatic fixture, and also programming. So from the drawing to the final part with only one supplier. Furthermore, we can offer also different kinds of configurations suitable for multiple applications, 2D and 3D cutting with the same machine, welding, and tube processing. Obviously, in case of special requirements, we are available to develop special machines based on our standard products with tailored loading unloading solution or something else according to the customer requirements. So we can offer from one side standard products, but on the other side we are also available to listen to the customers and provide customized solution. Now let's talk about the next challenges. So what is, in our opinion, the next challenge for the 3D laser cutting? Until now, 3D laser is mainly a cell where we have maybe a table with the fixer at part on, sometimes a turntable, with an operator that load and unload the parts and check if the part is well cut or not. We think that the future of the 3D laser machine is a better integration in the customer production flow. So no more independent and isolated cells with operators, but automated lines that are typical in the car maker's production environment. But until now, the 3D laser was not so well included in this production flow. So we are talking about the most flexible tool, the laser, but with some limitation that don't allow to insert this technology in the best way inside the production flow in the automotive production lines. So we think that there are some points, some key points to make this step further. And these key points are inline quality check after laser process. So we don't want to use the operator to check the part, but the machine can analyze in real time if the part is well cut and give a 100% check of the parts. And then we think that it's very important to have an input to the line, to the laser cutting, something that can enhance the flexibility of the laser. I'm talking about a real-time analysis of the parts in order to simplify the fixtures, modifying in real time the program, the part program of the machine. At the moment, we have to fix in a very strong way the part on the fixture. And it's very strange because we have to fix in a strong way something, and then we use the most flexible tool. So it's easy to see that we have something to do about this. So if it were possible to measure the system and to understand how it's positioned inside the machine, obviously in a very short time, we can adapt the part program and avoid very strong and expensive fixtures. And we, furthermore, we can avoid the difficulties connected with the loading operation that can be done by robots in a very simpler way. So these are in our idea the future challenges of a 3D laser, to get no more the 3D laser something that is necessary for car makers to cut the hot stamped parts because they are forced to use this instead of conventional cutting system, but an added value for their production lines, and to include the 3D laser better in the production flow, because laser is the more flexible and efficient, accurate and fast tool that we have. So I think we have to improve in this direction. So this is my last slide. I thank you for your attention, and I'm available to share my opinion to other people.
There is a lot of things that we need to discuss here. I'm honored to have TRUMPF and Prima back to back. It is really great to have you here. I would like to address many different topics. We only have 9 minutes, so let's start with the topic of real-time sampling of the beam. And for that, we have hollow ore in the room. Karen, can you share your concern here? I think I would like both of them to address this.
Yeah, sure. Thanks for that. Marco, you mentioned that you're interested in real-time measurement of the process, and I'm wondering if real-time sampling of the beam can assist you in that, because you can split it in a way that a very small portion of the beam would go to the detector, and then you can check what the level of the beam is at any time during the process. So is this something that can be relevant, that can assist you in that aspect?
Okay, when I talk about the measurement of parts, I'm talking about the measurement of the shape of the parts. So you know that when the parts are coming from a press, maybe they can be not exactly like the drawing. Okay, so it's important to have a fast system to understand if the shape of the 3D part is according to the drawing. Otherwise, I have to force the part on a fixture in order to cut it well. If I can detect the the actual shape of the part, I can adapt the program of the laser to the real shape of the part, and I have not to force it on a fixture to get the right geometry. This was I mean when I talk about measuring system of the parts before the cutting. Furthermore, it's important also to see the part with a vision system or a scanner to understand what is the position of the part inside the working area. And in this way, I can adapt in real time the program to follow the right path during the cutting.
And are you looking for a complete solution for that, for the 3D measurement of the part during the process?
Yes, I think that one measure can be made outside also the process, the cutting volume outside of the machine if necessary, and this is to understand how much the part is different from the theoretical shape. Okay, so in this way I can evaluate the quality of the stamping process. Okay, then the second part of the analysis, it's more easy, and it can be done inside the machine. It must be done inside the machine, and it is about the positioning. So I can save time and I can save money in complex jigs for during the automatic loading with the robot. If I can position in a rough way the part inside the machine, because then
today, Marco, when we had the previous presentation from Markus, and I came here with my S-Weird cameras and your camera, he gave me a hit of reality. Markus from Precitec, he said, boom, to me, price, cost, throughput, but price and cost. Marco, you have made Prima is making a big difference in the use of adaptive optics to actually have a good measurement of different depths and different material layers when it comes to the cutting. Do you have some information on that we could share here? We have companies like Optocraft in the room. Is there any room for cooperation on adaptive optics on wavefront sensors? Marco?
Yes, we already have an adaptive optic on our 3D laser head. We use also solutions in our 2 laser machines with the adaptive collimator. And obviously, I think we are available to consider solutions in this kind of application. We use an adaptive optic on our 3D cutting head to manage the focus position. So
okay, so on that, I believe there is much room for cooperation there. You're making a bit difference on a stamp steel, and there is where you really need to have an accurate measurement. Where do you stand on thermal cameras? S-Weird, M-Weird, L-Weird? Is there, in your opinion, an application for cutting? Can we convince Markus from Precitec on the use of these cameras, even though they are a bit more expensive than a photodiode? I'm coming back to you, Markus. You know I'm coming back. Marco from Prima.
Markus or Marco?
First Marco, Prima Marco, and then Markus. Precitec
Okay,
Markus.
Prima Marco. Okay, yes. Okay. No. At the moment, about the camera mounted on the head, we use camera for visual inspection of welding. We use cameras for programming. Related to welding process. About the process control, and not in 3D laser, but in 2D, we use photodiodes. And I agree with the comments made by Markus before, and In the past, I took part to the development of this sensor based on the reflection from the processor made by photodiode, and I agree with Markus about the efficiency of this approach. But never say never. We can also take into consideration also alternative to this sensor.
Markus, I said your name 3 times. You need to say something here.
Yes. So for sure, maybe you know that the job I'm actually doing at Precitec is to oversee all funded projects. So that is why we are working together with NIT already in some of funded projects. So, but it's all joining. It's additive manufacturing, it's welding, and it's not cutting. Cutting is, as I said, that price sensitive that I don't see any kind of camera technology, not even a cheap CMOS silicon camera in our cutting heads in the near future.
I'm gonna quote you on this, Markus, and you're gonna buy me dinner if this happens.
Okay,
otherwise.
okay.
I don't eat a lot, so that's okay. But
no, fine. So,
Benjamin,
I would like to see.
There is something that I would like to address here, Benjamin. You are here scouting technologies. We heard from Precitec, we heard from Prima, we heard from TRUMPF, and I wonder because Markus is very engaged with European Commission projects, and me too. We went to the Commission. We knocked on ways for Infineon and end users like you to test these technologies, to have access to advanced and 3D printing manufacturing. And Francesca has something cool to tell you, Benjamin, and the other end users in the room. Frank, what's on your mind?
So let's see if I'm very bad in sharing. I am. So sorry for this. Away. Now you should see my screen clean. Yeah. So thanks a lot, Jose, for this introduction. So here today, I'm just introducing something that is called Pulsate. So a European funded initiatives that most probably also Markus heard of. So our aim is exactly to bring laser-based advanced and additive manufacturing service closer to SMEs and also mid-caps, let's say a bit larger companies that still didn't have the opportunity so far to really get used to it and get really in a way to integrate it. So of course, laser additive is one thing, but for advanced, we intend all possible laser-based technology where actually also a further step like in automation, it could be robotics, it could be also machine learning that is introduced there. It sounds very expensive, Markus, right? But we want to bring it close to them, and so maybe get a breakthrough also there. So the idea is that we have 6 competence centers in our consortium that are all experts in different fields of laser-based manufacturing and additive manufacturing. And what we actually maybe ring a bell to you is we offer also cascade funding. So we have a lot of services that will be like training and also on-spot support, but also real money that we distribute in 2 different kind of calls that are called technology transfer experiments. That means a bit longer project. So over a year, 13 months, up to 150K euros for one technology provider and one end user that wants to learn from the technology provider. And a second kind of call that is actually the next one that is approaching. So is Q1 2022, because the first one of TTE, so the technology transfer, is just closed. But this one is for adopter use cases, and that means that we will offer a mini project, so of 3 months with a financial support of 25,000 euros for basically technical and economical feasibility assessment for the only winner of, so for the appliers of the call. So of course we will have more than one, but let's say it's more a solo project to basically learn from the expertise of the consortium we have. So my suggestion is for those who are listening also on YouTube, if you want to get closer to the laser technology, of course, here in the room, we had a lot of experts, but they are maybe willing to help you and maybe through these calls also support the diffusion, let's say, of laser-based advanced and additive manufacturing services. Thank you. So if I may, Jose, one last question. Otherwise, I break my promise. I have to ask Marco, can you specify a bit you were talking about robotics and introducing more robotics. That is also expensive, but the robotics company want to hear because I know that. Can you give a couple of specs on how this robotics and automation, also maybe with machine learning, this is what I got from your last slide, is that Prima has in mind, or Prima would like to discuss at least? This is already something.
Yes, we have in mind to improve the automation around our machines, 3D laser cutting machine. But in our idea, we have not only to replace the human operator with a robot. We have to redesign the cell or multiple cells, multiple machines, in order to be served by robots. So in my idea, there is, instead of the single cell with the human operator, we can have 1, 2, 3 laser machines, 3D laser machine, according to the production rate of the line. And in front of the machine, there can be one or more robots for loading, unloading, and check the parts. And if I can simplify, I can understand better what is the shape of the parts and what is the position of the part through the vision system, I can simplify the job of the robot. Otherwise, I need the robot with the vision system to recognize the part, to put it and place it in the right position inside the machine. So today, with the robot, we must have also this feature, vision to recognize the part, to take it in the right way, mainly on positioning reference and so on. In the future, our idea is to use the robot in a very fast way and without an accurate positioning of parts. We have in mind simple fixtures where a vision system can in real time understand the position of the part, understand the shape, and adjust part by part the part program. This is what we had in mind. After the cutting, we would like to include in this big cell the control of the proper cutting of the parts before sending them to the assembly line. This can be made by the robot during the unloading phase or inside the machine at the end of the cutting. If we make it inside the machine, we can also correct, if possible, something wrong. If we make the control outside, maybe using the robot or a station dedicated to the check, we have to scrap the parts in case of failure.
Marco, thank you very much for a very, very, very interesting meeting. And we are 5 minutes out of time. So I need to tell you that it was very, 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 very good because we have spotted 4 big challenges with room for cooperation. First, the monitoring. And there is the challenge there on cost and throughput. Acoustic sensors were presented by Optoprim. It got a lot of interest. Photodiodes are the current solution. Thermal cameras are my passion. Fiber or CO2 lasers. All of you told me that the transition is a little bit towards fiber lasers. Beam shaping. The challenge is of fast, dynamic beam shaping, a collaboration between MPS and Kylabs, maybe in the right direction, and further digital integration with robotics, enable control software. We are going into that. This is the first of many activities on this topic, and it was amazing to have Infineon, Prima, Precitec, and TRUMPF showing their challenges. Let's enable cooperations. And that concludes the public part of today's meeting. If you are in our Zoom room, our informal private discussion is about to start. I call it virtual drinks with friends. And we all know follow-up is important. But for now, if you are watching on YouTube, That's where we leave you for today. Thanks to the epic production crew and our sponsors for making today's event possible. More details about upcoming meetings are on our website, and if you want to get in touch with any of the participants, all you have to do is contact me directly and I will make sure you get introduced. It is all about connections. Thanks for being epic.